Guys, this is Danny here. Today we're gonna talk about block scope, and we spent about 4 or 5 videos on talking about what function scope is and what function is to JavaScript. And function is very important to understand because everything is basically all around function and variables. And what function basically is in JavaScript, there's only one unit of scope, and that is function. And I talk about this in my previous videos. I'm gonna assume that you know what function scope is and how it works. You saw all of the compile time versus running time, what happens. If you don't, you might want to go back and check out all those videos to really fully understand what this is all about. Today we're gonna talk about block scope today, and I said the only unit of scope is in JavaScript. However, in ES6, they created this let keyword, which binds whatever decoration you create right after to the outermost closest block, and it only exists within that block, which makes it getting stored into that block scope. So, um, so block scope exists, and just like Ruby, I come from Ruby background, and again, all these things that I have learned is this is my video blog that I'm putting out for my journey with how Simpson's You Don't Know JavaScript, and it explains everything in detail. So you might want to go check out that book and save yourself about 6 months of studying from online. Or if you find other good resources, it's really good, but I recommend I really recommend it. I really do because talks about all these concepts. I felt like JavaScript has all these concepts that you really need to understand. But anyways, here we go. We're gonna go through the actual compiling phase and then at the runtime, and I'm gonna show you how everything works. Okay, so at the compile time, when you press enter, what happens is that the compiling phase begins and the compiler goes in and tries to convert all of these source codes into binary codes that computer can understand. And it looks at all of these, and then first it sees this function declaration, and function declarations are any statement that start out with the function keyword is a function declaration. So it creates a function declaration, and every time function declaration is created, you recursively go back. This is one thing you just have to memorize. You recursively go back and construct the function scope or the function object. Both statements are true. It is an object, and function is also a scope. So it goes in and it constructs it. And this is a default behavior of function declaration, even when any function is created, object is created. The default action is it goes in and finds all the variable declarations and function declarations and hoists it, raises it up, and stores it into the function scope that is currently being constructed. So it goes in and it looks for any variable or function declaration. It does not exist, so nothing gets stored into foo scope. But let's say we did something like variable focus. This is a variable declaration, and what variable declaration is every time you have a var keyword. And what would happen is variable focus will be declared and get stored into the scope of foo. But in this case, we don't have it, so whatever. But that's what happens. Oh, here's one thing that I have forgot to mention: var. Right? Every time you have a parameter variable, we all know that this is a variable that contains whatever you send in, like right here. Immediate value string will get stored into var. So var equals block scope with that keyword, right? But this is an implicit variable declaration, so it's the same thing as var bar, and whatever user put in, like that. So what happens is that variable bar will actually implicitly get declared and get stored into the scope of function foo. Now, in the compile phase, all we're worried about, or when the function object is created, is variable declaration and function declaration. There's no function or variable declaration that exists anymore. So we are done with the creating function, and it gets stored away to the global scope because that's the scope we are in right now. So we go out and we look at this. Is this variable declaration? Nope. Function declaration? Nope. So we skip it altogether because the job of compile phase is to declare the variable declaration, communicate with the scope engine that it is currently under, and store it into the that scope engine or whatever that it is decorating needs to be placed into a correct scope slot. It's like that. That's what the compiler's job is at the compiling phase. So the compiling phase is done. A couple microseconds later, we're gonna go through a um, running time. We're gonna go to execution time. This is when we go again, read the whole thing, and then we're gonna execute it again. We're gonna execute the codes this time. And by the time at the runtime when we go in, this whole thing right here does not exist. Because you know why? Like we just said, function was created, object was created, we declared it, and we got stored it away to the appropriate scope, right? So now this exists. This is RHS reference to identifier called foo. And I talk about RHS versus LHS on my I think about last 2 videos ago. So you might want to check that out, and it's very important to understand. It's a communication. It's how a scope. It's how a JavaScript communicates with the scope engine to get all these decorations that we need back, that we have first stored away in the compiling phase. Now, at the runtime phase, the communication happens with these two terms, and depending on how you want to use them, these terms would change, and depending on these terms, how the scope responds to it is different. So it's really important. It's really important to understand that concept. But here we go. Assuming that you have checked it out or know what I'm talking about, this is RHS reference to identifier called foo, and it talks to global scope. Hey, global scope, do you have a identifier called foo? We need it, and it's for RHS right hand side purposes, which means we want to use it for purpose, not assign a value to it. We want to use it. So what happens is it's going to give us back this function object. And global scope goes, yeah, here you go. Yeah, you were declared in compiling phase. Here you go. And we got it, and we call it, and we send in a immediate string value. And then we're gonna now go back in, because this is the running time, this is the execution phase. We're gonna go back into the function declaration, function object, and start executing the codes. Now, notice that all the variable declarations, if there were any, would have been all stored away, and what's left are the codes that are not function or variable declarations. Right now, all of these are not, so they remain to be executed. Alright, so if, first let's start with the if keyword. If the statement is true, right? If bar is a truly value, which is it is because we sent in an immediate value, then we have this huge block. Okay, and what block is, it doesn't really do anything in JavaScript. It just groups the things together, except with if keyword. If the statement is true, then we could actually get or use the codes that is associated to that if keyword. And since it's a true value, we go into this block and we look at let bas. What is let bas? Okay, so let keyword, what it does is it whatever it's declaring, it declares the variable and assign a value, right? And then it's gonna bind it to the outermost closest block, and therefore it becomes a block scope. So right here, this is the block scope, and it binds it into this block scope, right? And so let bas, the variable declarations happens, and then it stores the parameter that we passed in, and then it binds it into this block scope, into this block, which makes it block scope, right? Because scope is basically what it contains, what it's stored. It's private, right? With private meaning that all the codes only belong into that scope. And from outside you can't reach it, but from inside you could reach outside. And that's the go fishing thing that I talked about in the last couple of videos, and that explains lexical scope. Anyways, so right here, so let bas equals bar, right? And one thing you have to know that unlike variable declarations, let bas, let keyword does not have hoisting, so it does not get hoisted into the at the all the way up to the block, that scope that it is in right now, and partially because this is at runtime. This is happening at runtime. This is not happening at compile phase. So there's no hoisting that's going on here. This is runtime thing, and it does not get hoisted. And so you just read it as it is. And this baz variable does not exist until it is read or run. Okay. So right here, let baz is created the moment it read. Assign the value to it, and then we go on to the next line. Right, there is another block in here. If the baz is true, which it is true because we created it and put a value to it, then we go in and we construct another let variable with called bam, and then we assign that value to it. So we have block scope with let keyword twice going on right here as a string value, and when that is done, we go down and proceed with console.log bam. Now what would that be, right? Okay, so what happens is, remember in JavaScript, block scope, what do you call? Even though these are getting attached to the block scope, right? It's gonna look, console.log will look at the scope that it is currently under, and we're currently under the function foo, right? So it's gonna look at foo and ask, hey, do you have a variable declaration called bam, right? And function foo goes, no, we do not have variable declaration called bam, right? Or let's say we did variable bam and we assign something, or let bam outside here, right? Let bam gets declared under this scope, so it will respond back to it. Variable bam will be under this foo scope, so it will respond back to it. However, bam exists inside of this block, only inside of this block. So you could only access that variable inside of it. You can't do that either because, like I said, there's no hoisting. This does not get declared under, right? You execute bam, and then let bam is gonna be, it's gonna be created. So you have to call it after if you're actually calling it in here. So there's no hoisting involved, and that's very important. All right, so that's gonna raise an error because it's currently under this scope right now. Oh, did I say foo? I'm sorry. Well, it's gonna first look at this, this block, and it doesn't exist. And well, let's think of it like this. Let's think of it like this. It doesn't even look at the block, right? If there's a let keyword, then it will automatically respond saying we have a bam, right? But because in JavaScript, function is the main focus. If the let doesn't exist, then obviously he's just gonna look at the function scope, and that's the primary focus, and ask for bam, and it doesn't exist. And then it goes outside, it looks at the global scope. Hey, do you guys have bam? No, we do not. And then when that's done, let's see. When that is done, we go out to console.log baz. Okay, what happens here? We're now, let's make this clear. We're now out in function scope, right? We're inside of this function scope. We're not inside of this block, okay? And we'll go, hey, console.log baz. Do you have a RHS reference called baz? And then the function scope foo goes, no, we do not, because there's no variable declarations, nor there's no let keyword that binds to the block scope or creates this block scope. So I guess it's easier to say that every time you have let, there's no block scope in JavaScript. What it basically does is whatever you create with let binds itself to the block, which kind of makes it look like there is block scope. But it binds to the block and only exists within that scope. So don't think that block scopes exist. Let keyword just binds itself to a block, which makes it look like there's a block scope, but really there isn't. So really, it looks at the scope of foo, and then goes, hey, do you have baz? No, we do not. We go outside to the global. Do you have baz? No, we do not. So it raises an error. And that is it. And that's the whole thing. So that's basically how a let keyword works, and all of these. I hope this was a lot clear. If it wasn't, you could leave a comment, or you could go read the book. I recommend going read the book. It has so much details. There's like a lot of examples, and you're just gonna get it. And it's not really boring either. He doesn't write it in a super complex, like English or something like that. English is my second language, so it's really easy to understand. It's great for beginners too. So here we go. Next time we're gonna talk more about hoisting in depth and how to respond to it in deep, not like in a more is more in difficult examples. And I talk about hoisting because it ties in with this whole compiling, what happens in compiling and running phase. And I was talking about hoisting the whole time, literally, even when I was demonstrating what was going on in the beginning. But I'm actually gonna create a whole video dedicating to the hoisting. So again, all the credits goes to the book, and please read the book. And probably everything that I'm explaining is probably like not even 5% of what the book contains. So, all right, guys.